Hello and welcome back. Today we'll be looking at session 7, but before we begin, let's recap what we learned in session 6. We learned about the iteration, repetition, or looping constructs. We saw the various types of iteration or looping constructs, and we wound up the session by looking at nested loops. Let's look at the objectives of today's session, structured programming. Objectives. By the end of this session, you'll be in a position to define what is structured programming. You'll also be in a position to describe the benefits of structured programs, identify the modeling tools used for structured programming. You'll also be in a position to explain the top-down structured technique used in program designing. You'll also be in a position to explain the elements of structured programs. Let's get started. Introduction. Structured programming. Now, structured programming is also called modular programming, and it is a programming approach which applies a logical structure on a program to make it efficient and easier to understand and modify. It regularly uses top-down design model in which developers plan the whole program structure and then divide it into subsections. Benefits of structured programming. The advantages of structured programming are described as follows. We have code reuse. Modules can be used multiple times, and this basically reduces the complexity, it saves you times and increases reliability, meaning that you don't always have to write the code from scratch every time. Modularity. Now, modularity equips the programmers to confront problems logically by splitting the large problem solution into smaller portions. The smaller portions are what we are calling the modules. Better flow. Structured programming promotes better flow as each operation or task is properly segmented or separated, and there is increased productivity. Now, structured programming increases productivity as time taken for error detection and error handling is reduced, and there is easier debugging and maintenance of your program. It is also easier to update or fix issues in the program by replacing individual modules rather than modifying or fixing larger amounts of code. Because remember, we said you've broken it down into modules. Okay, we move on. Structured programming method results in a hierarchical or layered program structure. Now, here we have the main function, and it is from the main function that all these other modules will be called. Now, this looks like a word processor, and we can see we have the various functions. We have enter, we have edit, we have sort and print, and edit is further broken down into reading, modifying, and saving or storing the text in the hard disk. Then the task of modification is also broken down into deleting and updating the contents of a particular file. Okay, so this is what we are calling the breaking down your program into smaller parts or modules for manageability. And it makes your life very easy because if you're having problems changing your content or the text, then you're not going to look at the module for storage or the one for getting the text. You're going to look at the module which deals with modifying the what? The text. We move on. Unified Modeling Language. This is abbreviated as UML, and it is a popular standardized modeling tool used in structured programming and object-oriented programming systems. It is used to specify, visualize, modify, construct, and document the requirements and specifications of a software under development. It helps designers and developers to read and circulate system structures. It provides the formalization and visualization which make the requirements clear and concise. Basic UML legends that are used in different kinds of UML diagrams are given below. We have the note, we have the initial state, we have the final state, control flow, action, decision. We have a node, component, fragment, use case, actor, interface, and finally a socket. Modeling views offered by UML are given below. We have the sequence diagrams, the collaboration diagrams, activity diagrams, state chart diagrams, class diagrams, component diagrams, and finally we have the deployment diagrams. Structure charts. Now, a structure chart is a graphic representation of the decomposition of a problem, and it is a tool used to assist in software design. It is particularly helpful when solving large problems, And a structure chart is not a flow chart, and it has no logical sequence of tasks. A good example would be like the structure chart in an organization. Let's look at an example here. At the very top, you can see we have the chief executive officer, and we have these other officers who are below him. We have the vice presidents in the various departments and the general managers who are reporting to these vice presidents, all the way to the team members in the various teams. Okay, we move on. Top-down structure technique. This is the process of dividing the overall task into smaller components. We actually call this divide and conquer. And it signifies the breaking of a difficult task down and solving the pieces independently until every step can be easily implemented. It emphasizes planning and a complete understanding of the system, and it is implemented by attaching the stubs in place of the modules. And we have an example here. Let's say you're organizing an event. It could be your graduation, could be a wedding, could be a party, whatever it is that you want to do. We'll look at this example further in semester 4 when we are dealing with the project management. And for that, we'll be using this as organizing your graduation. Now, when you're organizing an event, the main events you'll do are planning, arranging the venue, gathering the support materials, sending out the invitation, and maybe booking the facilities and such. Let's look at planning. You have a team that is going to plan for your event. It could be several people. If you're doing it alone, then you'll be the team. You need to come up with a date for that particular event. Of course, you need a budget, an agenda, and the people who are going to be participating in your event. After that, you arrange the venue, you get the accommodation, and in case it's somewhere people need to travel, you can arrange for travel. You also get the support materials which are required. The support materials for your party or event could be things like the tents, the chairs, tables, and such. Of course, these participants needs to be invited. Therefore, we send the invitation. You can also invite speakers and other participants as well. Then for the facility, you'll actually decide whether you're going to cook for your guests or you're actually going to order for outside catering and the equipment which will be needed. This could be things like camera, speakers, and such. We move on. Now, elements of structured programs. Now, for developing structured programs, there are 5 elements which are used in most programming languages, and they are given here. We start by looking at variables. Now, a variable basically represents the data, and the data can range from something very simple, such as the age of a person, to something very complex. We'll actually see this in later or subsequent semesters. We have the loops, which we looked at in the previous session. And what these actually do is that they allow you to carry out execution of a group of commands a certain number of times. We have the conditionals. These are the decision-making constructs we looked at in session 4. And basically, they specify execution of a group of statements depending on whether or not some condition has been met or satisfied. We also have input and output, which allows interaction of the program with external entities. Let's say you could have something like a registration form where users interact with your program by registering and creating accounts. Could be something like a login form where people are required to authenticate before they access the system. Output could be the feedback given by your program to the users. And finally, we have the subroutines or functions. And their work is to allow putting frequently used snippets of code into one location. And then we can use or reuse this code repeatedly. This actually makes your life very simple. Instead of you having to rewrite that code every time, just put it in a subroutine or function and call or invoke that function. With that, we've come to the end of this session. Let's look at what we've covered. Structured programming is a programming approach that implements a logical structure on a program to make it competent and easier to comprehend and modify. UML is a popular modeling language used to specify, visualize, modify, construct, and document the requirements and specifications of an object-oriented software system. A structure chart is a graphical representation of decomposition of a problem, and it is a tool used to assist in software designing. Top-down structured technique is the process of dividing the overall task into smaller components. Now that is the end of this session. In session 8, we'll be looking at arrays and the various sorting and search algorithms. Have yourselves a lovely time. God bless. Bye and see you in the next session.